An initially stationary cart is being pulled by a force P. What is the velocity of the cart at t equals 4 seconds? So this is what's happening. We've got a 20 kilogram cart and it's being pulled to the right with a force P of t. Now P changes over time according to this graph. And as you can tell, the graph looks like this for 0 to 2 seconds and looks like this for t is between 2 and 4 seconds. So how do you solve this problem? Well, the first step, as always, is to draw a free body diagram, right? And on your free body diagram, you'll have one force already given to us, P of t. You'll also have another force, our force due to gravity, mg, and of course you'll have your normal force, N. The next step is to recall the impulse and momentum formula, which is the integral of the sum of forces acting on your object, dt, is equal to mv2 minus mv1. This is our impulse and momentum formula. Now we can apply this formula in both dimensions, x and y, if we wanted to, but you'll find that applying this in the y direction is pretty much meaningless. It won't give us any useful information. So I'm only going to apply this formula in the x direction. Okay, well, if you were to apply this formula only in the x direction, you'll notice that the sum of forces on our block in the x direction is just P of t. That's the only force there. So it's P of t. Notice we're neglecting friction, right? And don't forget we write dt here, right? And of course, our limits of integration will be from 0, our starting time, to 4 seconds, our final time. And that's going to be equal to m v2. And we're going to subtract that from m v1. Now, because our cart is initially stationary, that means that our initial velocity is 0, right? So we can now focus on the left-hand side now, since the right-hand side's been as simplified as it can. Well, what is the integral from 0 to 4 of P of t? It's a little bit tricky because our curve changes over time, but what we can do is we can actually split this integral into two separate integrals. We can split it into the integral from 0 to 2 of P of t dt plus our integral from 2 till 4 P of t dt. And that's going to be equal to m v2. Now I know what some of you might be thinking. You might be thinking, well, this is just the integral of P of t. Isn't that just the area under this graph? And yes, you're right, it totally is. So if you wanted to, if you feel more comfortable, you can just calculate the area under this graph, which is just going to be the area of a rectangle plus the area of this triangle, right? And you can do that, no problem. You'll get the same answer, I promise you. I'm going to do this using the integral method. And the way I'm going to do this using the integral method is to draw our curve again in a little bit more detail. So this is t, this is p, this is what our curve looks like from 0 till 2, right? And now what is the equation of this line from 0 till 2? Well, we know because it passes the origin, it has the form p is equal to mt, where m is the gradient of our curve. Now notice that our gradient is just the rise over run, which is just going to be 200 divided by 2, which is 100. So let me write that in here. It's just going to be 100t. That's going to be the equation of our curve from 0 till 2 seconds. Now, what's the equation of our curve from 2 till 4 seconds? Well, it's just p is equal to 200, right? It's just a horizontal line at p is equal to 200. So we can actually plug these values in here, and this is going to turn into 0 till 2 of 100t dt. Notice I can do this because I'm only integrating from 0 till 2. That's within this domain. So that's why I'm plugging p of t is equal to 100t. That's what I'm doing. That's the whole reason I split this integral into two separate integrals, right? And we're going to add this to the integral from 2 till 4 of just 200 dt. And of course, our right-hand side is going to be equal to 20 v2. Our mass of our cart is 20 kilograms. Now, what is this integral evaluated to? Well, if we were to go through the maths, 100t integrated turns into 100t squared on 2, which is just going to be 50t squared with limits from 0 till 2. And we're going to be adding that to, let's see, it'll just be 200t with limits from 2 till 4. And that's going to be equal to 20 v2. And if you were to go through this, I'll shortcut this a little bit, but if you were to go through this will be 50 times 2 squared, which is 50 times 4, which is going to be 200, right? 50 times 4 is 200. And then we're going to be adding that to 200 times by 4 minus 2, which is 200 times by 2, which is going to be 400. And that's going to be equal to 20 v2. And I don't have enough space, but I'm just going to continue writing up here. And if you were to evaluate this on the left-hand side, hopefully this isn't going to lose you, we're going to have 600 Newton seconds just here. And on our right-hand side, we're going to have 20 v2. v2, okay? And when we finish solving this, we can tell that v2 is simply 600 divided by 20, which is 30 meters per second. So that means that our cart, after 4 seconds, is 30 meters per second to the right. I hope that made sense, guys. Cheers.